Good morning, seventh grade. We are in the middle of Wacky Wednesday. Mr. Garrett's got the yellow legal pad out. We're doing the notes on yellow paper today instead of white paper. Just figured I'd shake things up a little bit. Let's get started. So we're doing chapter 1, lesson 4, properties of real numbers. Now, this first section of notes, first page of notes, I've got here in front of me. A lot wrote down. We got 5 different properties that we're going to cover before we jump into any actual problems. So make sure you're getting these down and you're getting down kind of the gist of all of them as well. First property that we're going to look at. These first two should be somewhat familiar to you. You should know the commutative property. Now, next to commutative property, I put the word order down, and that's kind of the key word that goes with the commutative property. The order of the way we write things, that's what makes this property what it is. So if we were to do this property through addition, maybe I started out with A plus B, well, that would be equal then to B plus A. Same thing with addition. Maybe I change that addition symbol to a multiplication symbol. So now I have A times B is equal to B times A. So it works in both ways. It works through addition, and it also works through multiplication. Maybe we were to put some numbers in for it. So I had 3 plus 2. Well, through this property, that would be equal then to 2 plus 3. And we could say the same thing for multiplication, just putting in a multiplication symbol where there is an addition symbol. So that's the commutative property. The fact that I can change the order around and it's still going to give me the same answer. I'm still going to get 5 on the left and 5 on the right, regardless of the order in which these numbers are wrote. Next property. The next property is the associative property. And my keyword with the associative property is the word grouping. This entire property deals with how we group things and how we solve them when they are grouped. So for example, if I had here A plus B plus C, well, because of order of operations, we would solve this A plus B first. So that's what the parentheses means. Whatever's in parentheses, you solve that first. So A plus B I would solve first and then add that answer to C. We would put that equal to, because of the associative property, I could do A plus B plus C, where I would do the B plus C first. So regardless, I still get the same answer even though I solve a different problem first. So I'm grouping together on the left the first 2 numbers, whereas on the right I would group together the last 2 numbers. And this only works whenever we're adding three or more things. Same thing can be said with multiplication. Say I were to be multiplying more than 3 things together. Well, it doesn't matter which 2 numbers I multiply first, I'm still going to get the same answer. Let's kind of see how this makes sense. So if I were to plug this in where I had 1 plus 2 plus 3. Well, based on my parentheses on the right, that would turn into 1 plus 2 plus 3 then on the right. So notice my parentheses, guys, are in different spots. We solve parentheses first. So on the left, this is going to turn into 3 plus 3 is equal to, well, on the right, it's going to be equal to 1 plus 5. So 6 is equal to 6. So I'm still getting the same answer regardless of which I solve first. But with the associative property, I'm just grouping off the different numbers that we're adding or even multiplying, okay? Number 3, the next property we're looking at, guys, this is the identity property. And the key with the identity property is I want to get back to the number that I started with. So for addition, if I start with the A, and A, guys, is just a variable. It can mean any number. It could be 5, could be 16, could be 6,000. But anyhow, with the identity property of addition, whatever number I start with, I want to get back to that original number. And the only way to do that is to add 0. So through the identity property of addition, we're doing A plus 0 is equal to A. And this looks like, in number form, 7 plus 0 is equal to 7. And that's just an example using numbers. Again, there's more than one way of showing this, but that would be through the form of addition. Through multiplication, again, if I want to get back to a, this time I can't multiply by 0 because a times 0, that's equal to 0, and I want to get back to a. So the way of doing it through multiplication is to multiply by 1. So with the identity property, it depends if you're doing multiplication or addition as far as what that next number is that you're using. So here, maybe I plugged a 17 in for a. 17 times 1 is equal to 17. So I still got the same number I started with. Through addition, I added 0. Through multiplication, I multiplied it by 1. Moving ahead, next property. So the fourth property, this is the 0 property of multiplication. And this property is one that every one of us should be familiar with. Essentially what it means is if I multiply any number by 0, my end result is going to be 0. So if I were to plug 12 in for a, if I take 12 times 0, I get 0. So again, we're multiplying anything by 0. We're getting 0 as our final answer. All right? Not really going to do a whole lot with that property just because it's one that we are very familiar with. Number 5. The last property that we're going to look at is the multiplication property of -1. And again, this is a property a lot of us should be familiar with as well. If I start with any number that represents a, and I multiply it by a -1, the only way my answer is different from a is that it's now negative. So if I were to have, for example, 3 times -1, well, because I'm multiplying it by 1, I'm still getting 3, but because it's -1, it just makes it into -3. So again, we're just getting the exact same thing that a is, but this time it's negative. Now the only way, guys, that this is going to be different and where you don't see the negative sign visibly is maybe if I use -2 as my starting number and I were to multiply that by -1. Well, a negative times a negative is going to give me a positive. So this answer would be 2. So I guess one way of looking at this is, okay, whatever a is, my answer is going to be the opposite of a. So it's going to be that same value, but the sign would just be an opposite then, okay? So these are the 5 properties that we're looking at. You may be thinking in your head, what about the distributive property? We're not going to cover the distributive property in this lesson. Matter of fact, I believe, I'm looking ahead right now, I believe our next lesson focuses on the distributive property. So it kind of has its own little piece by itself, okay? So these are our 5 properties. Have them wrote down, be familiar with them because they are going to be what the rest of our lesson is about. So let's go ahead and let's move ahead into our first set of problems. So numbers 1 through 4. With these problems, guys, you do not need to solve them. I just want to write what property is being shown. So if we look at number 1 and it says 42 times 0 equals 0, I just want you to tell me what property is being shown here. Well, we're multiplying by 0. We got a 0. So the only property that this could be is the 0 property. And we have to make sure that we show what operation we're doing. So it's going to be the 0 property of multiplication. And that is it. That's all you have to do for numbers 1 through 4. That's all we're doing with these. We're just listing off what property this is. Guys, if you are looking at these and this is new to you and maybe you're a little stuck on it, the reason you should have wrote all these notes down is because you can go through here and you can see which one it looks like. So notice my 0 property multiplication, I'm taking a, times 0 equals 0. Well, on number 1, I'm taking A times 0 equals 0. So it matches up perfectly. So here we have it, the 0 property of multiplication. Let's look at number 2. With this problem, we had y plus 2.5 plus 28 equals y plus 2.5 plus 28. So it's the same thing on the left as the right, except for this time the parentheses, guys, are just in a different spot. Remember, this is grouping. So anytime we group something, we're working with the associative property. And again, you would be counted wrong if you don't include the operation. So it's the associative property of addition. I am running off the page. But if you leave it as just associative property, it is wrong. You have to have the of addition because you're working with that operation here in number 2. Let's move ahead to number 3. So this time we have 10x plus 0 equals 10x. Well, remember, back with our properties, which one of these dealt with when I'm adding with 0? That's going to be my identity property. I get the same thing that I started with. So on number 3, my answer is the same thing I started with because I added 0. So this is going to be the identity property of, and again, we're adding, so it's going to be the identity property of addition. Last one, number 4. So here we have x plus the square root of y plus z is equal to x plus z plus the square root of y. As you look at this, you should already kind of look at it and be able to tell yourself, hey, they're not in the same order on the right as they are on the left. I have x, y, z, and on the right I have x, z, y. So my order is different. Well, whenever we're talking about order, we're working with the commutative property. And it's the commutative property of addition because we're adding all of our numbers together. So there you have it. There is numbers 1, 2, 3, and 4, just listing off what property is being used. Let's move on. Number 5. So number 5, I start with this problem, 7.75 plus 2.40 plus 1.25. It's important that you have the parentheses, guys, the same way I've got them here on the page. The goal of this, I'm going to write it off to the side, is to solve this problem using mental math. So that means no calculator. As I solve this problem, I also want to be able to identify the different steps that are being used. So if I look at this problem number 5, and I want to solve it mentally without using a calculator, there's one thing that already sticks out, and that is this 7.75 and this 1.25. And they stick out because of their decimals. And I know that 0.25 and 0.75, they're kind of like quarters. If I add a quarter to 0.75, then I get a next dollar up. So I'm going to rewrite this as 7.75 plus 1.25 plus 2.4. And I'm going to keep those parentheses now around my next two set of numbers. So between this first step and the second step, what properties do you see? Well, we changed the order around. So because we changed the order, we have the commutative property. And it's going to be the commutative property of addition. And then you also, guys, you should be able to see as well, I changed the grouping because I changed this from 7.75 plus 2.4 being added together first where now I'm adding together 7.75 and 1.25. So now those two numbers have been included in parentheses. So I've actually included both the associative property and the commutative property kind of in one step. All right. So we're going to list off, guys, any properties that we see whenever we're solving any of our problems together. So now I'm going to go through and I'm going to continue solving this. So I can mentally add these two numbers together. If I add this dollar over, it's going to be 8.75. I add the quarter in, it's going to be $9. So 9 plus 2.40. Really no need to write a rule here. If you were to write one, you would probably just put, guys, simplify or add the parentheses, but there's really no need to write a rule because we're not doing any of our specific properties. And then my final step, I'm going to combine my two numbers now. And whenever I add 9 to to 2.4, well, 9 plus 2 is 11. I add on my decimal, I'm going to get 11.40. And there you have it. There's your final answer. So when you solve any of these problems, make sure you list off what properties are being used. This problem should be something all of us can do. This is very much kind of getting back to the basics with adding and multiplying. But what we need to make sure we do is include those properties involved as well. Okay? All right, let's move forward. We've got just a couple more problems and then we'll be finished. So let's look at number 6, 7, and 8. Through these problems, guys, your goal is just to simplify. And you're going to simplify using those same properties that we used, okay? So this time, I have 5 times 3n. Not a big fan of this problem, only because this does use the distributive property, which we did not talk about. However, if you distribute this 5n, and I multiply these two numbers together, you're going to get 15n. And that would be a final answer for this being simplified. Let's move down to number 7. So I have 4 plus 7b plus 8. You cannot add a number with a b to a number without a b. So I need to rearrange this a little bit. So I'm going to have this now as 4 plus 8 plus 7b. And I'm going to regroup this together. Guys, on the questions that just have you to simplify these, you don't need to necessarily write the properties out. I just want you to be familiar with them so you know that you can switch this order around to get this into something that you know how to solve. So 4 plus 8, I can solve that. That gives me 12. 12 plus 7b. And that would be your final answer. Now, just kind of nitpicking this one a little bit, you actually would write your variable first. So it would be 7b plus 12. However, I would take either one of these answers. Last but not least, let's look at number 8. So I have, this time, guys, I have a fraction. I have 7x times y, 7 times x times y, all over y. So y is in the denominator. Now, I want to ask you something. What happens if I do 3 divided by 3? Well, if I divide the same number, one over the other, I get 1. Doesn't that look very similar to doing y over y? So it's almost like, guys, my y's cancel out. So I'm just left with then 6x. And 6x would be your final answer. The reason, guys, these cancel out is for the same reason that 3 divided by 3 equals 1. I could rewrite this as 6 times x times 1, but it's kind of redundant because 6 times x times 1 is 6x. So there you have it. There's your final answer. So anytime you have a variable over a variable, those can cancel each other out, and you're just kind of left with whatever's left over. So this time it just happens to be the numerator as 6x. All right, I think guys, number 8 is probably going to be the most difficult, and that's just because naturally with these problems, our fractions are a little more intimidating just because we're a little more unfamiliar with them. All right, let's move ahead. We've got 2 problems left, and then we will be finished. Hopefully I didn't move too quickly today. If you do have any questions, shoot me an email, leave me a comment after this video, and we can kind of go from there with it. All right, so for number 9 and 10, these are proofs, and we needed to tell if they're true or false, and if they're false, I need to state why. Or if it's false, I need to give a counterexample. So I need to prove it by saying something that's true. So for all real numbers, a and b, a times b is equal to b plus a. And what this means is if I plug any number in for a and any number in for b, will this always, that's your key here, will this always be true? If I do any number for a and any number for b, will this always be true? On these problems, my best hint is going to be, first, can you relate it to a property? Second, plug numbers in, plug actual numbers in. First off, do we have a property that mixes up addition and multiplication? No, we do not have a property that uses both addition and multiplication in the same property. So now let's kind of go through and let's plug some numbers in. So if I said a is equal to 1 and b is equal to 2, so that would mean I would have 1 times 2 is equal to 2 plus 1. Again, anytime it says for all real numbers, integers, decimals, whole numbers, counting numbers, any numbers. So 1 times 2 is 2, 2 plus 1 is 3. Is 2 equal to 3? Absolutely not. So this is not true. So this would be false. And I have provided a counterexample. This is a counterexample. I have proved it false by plugging in something for A, plugging in something for B, and finding that this be false. So there you have it. So that's how you would answer these questions if they were to be false. Let's look at number 10. For all real numbers, A, B, and C, A plus B plus C is equal to B plus A plus C. So again, my first hint, look at your properties. Can it match any of your properties? And this one actually does relate to one of our properties pretty well. I'm going to rewrite this one here. A plus B plus C. I want to try and make my right side look like my left side. I want them to be identical. So I'm going to move some pieces around. So maybe I were to move my parentheses over to B plus A. So by doing this, what property did we just use? Well, we changed our grouping, and anytime that we change the grouping, we're working with the associative property. So this would be the associative property that was just used. And it doesn't quite look like the left side, but I can do one more step where it looks identical. How can I do that? I can just flip this into A plus B instead of B plus A. And now my left side is identical to my right side. And I did that through the commutative property. So there we have it. This one is going to be true. So there you go. Number 10 is true. We have proved it true because we moved some pieces around. We showed those properties, and there you have it. So 9 was false, 10 was true. There you go. Guys, if you have any questions, let me know. Shoot me an email. Shoot me a kind of a message on our Google Classroom. But other than that, there you go. See you guys.